In today's lab, we will be doing an acid-base titration. A titration is an analytical technique where a solution of known concentration is used to determine the concentration of an unknown solution. Normally, the known solution is placed in a burette and is added dropwise to a flask containing the unknown solution. An indicator is used to highlight the end of the reaction. An indicator is a chemical compound which changes color at different pHs. In today's experiment, we will be doing an acid-base titration. In simple terms, an acid is a proton donor and a base is a proton acceptor. When an acid and a base reacts, the reaction is known as a neutralization reaction. In today's experiment, we will be using sodium hydroxide of concentration 0.09 mole per dm cube to determine the concentration of a sample of hydrochloric acid. To do this, we place our standard sample of sodium hydroxide into the burette and pipette 25 milliliters of the unknown HCl into 3 250 milliliter conical flasks. We then add a few drops of phenolphthalein indicator, which is colorless in acidic solutions but pink in basic solutions. The titration was then done until a light pink endpoint was achieved. There are 4 steps that you have to follow in order to find the unknown concentration of the hydrochloric acid. The first step is to find the number of moles of the known sample that was present. In other words, how many moles of NaOH were added to the conical flask from the burette. To do this, we must remember that moles is equal to concentration multiplied by volume in liters. We already know the concentration of the sodium hydroxide, which was 0.09 moles per dm cube. To get the volume, we simply average all the titer volumes from our results table. This gives us 23.82 milliliters. We then convert this to liters by dividing by 1,000. Using this information, the moles of sodium hydroxide added to the conical flask from the burette is equal to 0.02382 multiplied by 0.09, which gives us 0.0021428 moles. Next, we need to find the number of moles of hydrochloric acid that was already present in the flask before we started to add any NaOH. To do this, we look at the mole ratio from the equation. From the equation, we see that 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. Therefore, if we have 0.0021428 moles of sodium hydroxide present, we must also have 0.0021428 moles of hydrochloric acid present. Next, we need to find the concentration of hydrochloric acid present in the flask. Molar concentration is equal to moles divided by volume in liters. Remember, the volume of hydrochloric acid that we added to each conical flask was 25 milliliters. So, to convert this to liters, we simply divide by 1,000. The number of moles of hydrochloric acid present is 0.0021428. Therefore, the concentration of hydrochloric acid present in the conical flask is equal to 0.0021428 divided by 0.025, which is equal to 0.0857 moles per dm cube. Now, it is at this step that everyone thinks they are finished. Remember that the hydrochloric acid solution that is being used was made up from a more concentrated sample, and then diluted to be used in this experiment. The question your teacher may ask you is, what was the concentration of hydrochloric acid in the original solution? To do that, we simply say, since 25 milliliters contains 0.0857 moles per dm cube, then 1000 milliliters contain X. We can then cross multiply and solve for X.